Problem 170 talks about some compound interest. When we're looking at compound interest here, we're going to be taking a look at continuously compounded is this formula right here, dealing with E as the base. And our exponent then is our rate times time, and time is in years, then it's going to be. Our rate for this first problem then is 3%, so as a decimal that's 0.03. So for problem A, what we're going to have here is 10,000, that's our principal, times E to the 0.03 times 1. Now that exponent, 0.03 times 1, we don't need that times 1. It's just going to end up being 0.03. So this is essentially what I need to put into the calculator. And when I do that, I get a value of $10,304.55. This has been rounded. It was actually 0.54. And then the number after that, I believe, was a 5, and it rounds it up then to 55 cents. So when you compare it to the hourly, it's basically a difference of a penny. And one statement I do want to make here is this number is actually slightly off. If you go through and use the compound interest formula from the math notes box, this number, this last digit here of a 6 should actually be a 4. So it is a difference of about 1 penny. Now, when you get to problem B, there's a fairly significant difference here for that one. So what I'm going to do here is just make some room. And when we invest a huge amount, like $10 billion at 8%, and again, 8% is a very big difference as well from 3%, but $10 billion. And if that is being continuously compounded using our formula again, 0.08, now when I do this and put that number in the calculator, it's a fairly significant amount. So that ends up being $10,832,870, or $870,000 rather, $680. The calculator doesn't even give enough decimal places to figure out the pennies. At that point, it's not necessarily that big of a deal if you're dealing with $10 billion. The other formula then, if we're compounding daily, so again, that formula then is going to be our 10 billion times 1 plus 0.08, and if we're doing hourly, it's going to be 365 times 24. That's a multiplication there. And my exponent is 365 times 24, because that's how many times it's being compounded throughout the year. When we put that number now into our calculator and figure that out, we're going to have a fairly significant difference here. That total ends up being 10,832,775,720. Still a substantial amount of money, but when you subtract the two, there's a lot of difference right over here. So the difference between them is actually $94,960 more. So if you are investing a huge sum of money like that, so problem C, if you're investing a huge sum of money continuously, can actually make a substantial difference compared to even daily. And daily is compounding quite often. So just under $100,000 difference in 1 year.